pen or a pencil?
No. What do you need?
He needs a pen.
For. Oh. Oh, okay. Here. So our speaker will probably repeat your question and then on air. So when you do ask it, you may not have a microphone in front of you. Please speak up so that we can hear you. All right? Any questions? Okay. All right, good evening, everyone. Welcome back to the Vancouver Aquarium's Introduction to Marine Life course. Tonight's program is on seabirds. Our instructor tonight is a research scientist at Environment Canada. He's the director at the Centre for Wildlife Ecology's Seabird Research and Monitoring Program at Triangle Island. He has studied seabird biology and marine ecology. And he's conducted work in Alaska, Canada's Eastern Arctic, Newfoundland, Labrador, and British Columbia. He's dedicated to integrating pure and applied science to provide a more comprehensive understanding of seabird ecology and enabling the Canadian Wildlife Service to enact effective conservation strategies for marine wildlife. And I always like to say something that you don't normally read on a biography before we get started. Our speaker tonight is also an astute poker player, and he will claim that he doesn't know what he's doing when it comes to playing poker, but when he left my house with his pockets full of money, I didn't believe him. So anyways, tonight, our speaker, Dr. Mark Hipfner. Thanks, Mark.
Okay, thanks. Thanks, Jonathan. That's actually not the way I remember that poker game, but that's okay. So there's just a loop running here, and I think the plan is just to keep this going for a little while, and if anything interesting shows up, I'll let you know. This was footage shot by the Vancouver Aquarium when they came out to Triangle Island, I think about 2 or 3 years ago. They were interested in helping Environment Canada with development of the Scott Islands Marine Wildlife Area, and so they came out and shot some footage, and it was good fun having them out there. So I've never actually seen this except for the loops I've been watching. Tufted puffin in the air there. Those were common murres in the background, some glaucous-winged gulls. This is actually the largest tufted puffin colony in British Columbia. something on the order of about 30,000 pairs. It's actually the largest common murre colony in British Columbia as well. Okay, I can tell you these birds are a lot more graceful in the air and the water than they are on land. Just some general thoughts on Triangle. It's the largest seabird colony in British Columbia. There's about 13 different species breed out there. You can see the lighthouse up at the top of the island there. Was built in the 1920s and decommissioned, I think, within 10 years. Because it was basically useless as a lighthouse because the top of the island is covered in fog about 300 days of the year. There's the common murre colony. You can see that bird's carrying a fish in its bill. That's West Bay. About 50% of the world population of Cassin's auklets nest in that one bay there. Okay, so maybe we can get started. Okay, so what I thought I would talk about tonight, the layout of this talk, we'll start with a couple of fairly general things. We'll address the question, what is a seabird? From the standpoint of taxonomy and ecology and life history. Life history is what ecologists call the lifestyle of an organism. Then a little talk on the seabird community of British Columbia. Then some of the research we've been doing at Environment Canada on seabirds in the marine ecosystems of British Columbia. And then we'll talk about a little bit of conservation issues for seabirds in Canada. And again, some of the work that Environment Canada has been doing. Okay, so sounds like a simple question. What is a seabird? But in fact, it's not a particularly easy question to answer. Lots of people have different opinions, and so I think the definition here, I think most people would agree, these are what we would call true seabirds. So these are species belonging to 4 different orders. The Procellariforms, these are the tube noses, things like shearwaters and petrels and albatrosses, really deep ocean birds. The penguins, of course, like these emperor penguins. Some species of pelecaniforms, so these include birds like cormorants and gannets and boobies. And the charadriforms, which includes birds like gulls. Lots of gulls aren't entirely marine, lots aren't. Skuas and jaegers and auks and that group of birds. So for the standpoint of this talk, these are the birds we're going to consider to be true seabirds. Okay, my colleague Tony Gaston published a very excellent book in 2004 called Seabirds in Natural History. And Tony was my thesis supervisor and colleague at Environment Canada. He's just retired. And he's somebody who's thought an awful lot about this question, about the ecology and life history of seabirds. And so in his book, he describes what he calls the seabird syndrome. So what is it about seabirds that really defines them in terms of ecology and life history? And what Tony had to say was that the essential elements are scale and mobility, but constrained by the need to return to land to breed. So it's just one sentence, but there's actually an awful lot there. And I think it's also an excellent definition of what it is in terms of ecology and lifestyle that defines seabirds. So the ideas here are, first of all, that seabirds travel long distances in search of patchy and ephemeral prey. So here's Triangle Island. You can see it's a huge seascape, and the birds range far and wide from this island in search of prey because it's patchy and it's ephemeral. The second characteristic Tony refers to was constrained by the need to return to land to breed. So one of the defining characteristics of most seabirds is that they aggregate to breed in colonies, and these colonies can be very large. And then these two characteristics, long travel distance in search of patchy prey and breeding in large colony, these two facets of their ecology underlie a suite of life history attributes that are common to seabirds. Okay, so just thinking about seabirds travel long distances to find food. This is a Cassin's auklet out on Triangle Island. This past summer, we put some of these GPS devices on the birds. They only weigh about 2 grams. They don't really cause the birds any trouble at all. We deployed them on on several birds on Triangle Island, and then these units give you a track of where the bird went on that particular foraging trip. So I can tell you this bird, this Cassin's auklet, we put the device on him at about 2 o'clock in the afternoon. The bird spent the day in the burrow with its chick, left the colony at about 4 o'clock in the morning, traveled almost 100 kilometers out to the point furthest north here. It fed out here at the end of that loop between about 7 o'clock and 5:25 in the afternoon, going back and forth in loops. And then at 5:25, it took a return loop down to here, began feeding again at about 7 o'clock, fed quite heavily between 7 o'clock and 9 o'clock, flew over towards Triangle Island, staged here till about 10:50 at night, and then returned to the colony to feed its chick at 11 o'clock at night. So that, for a 200-gram bird, the total travel distance was something like about 250 kilometers. So these birds are traveling long distances. That's 250 kilometers in less than 24 hours. Okay, the second defining characteristic, seabirds aggregate in large colonies to breed. So this is a photograph of Funk Island off the east coast of Newfoundland. Historically was the largest great auk colony in the world, but of course great auks were driven to extinction when Europeans came to North America. It's now one of the largest common murre colonies in the world. I think it's something on the order of about 500,000 breeding pairs. So very large colonies. Okay, so you can imagine it's a fairly momentous decision to decide to try to breed in a colony that size. And as to colonial breeding, there are benefits and there are costs to doing this. So if we were to think about the benefits of nesting in large colonies, an obvious one that there's lots of potential mates around. Large groups like this prefer some protection from predators in two ways. First of all, because the group can defend against a larger predator. But the second thing is, if a predator does arrive, you're just one of many, many, many potential lunch items. So there's some safety from that perspective too. And then maybe the most important thing, we've talked about needing to travel long distances to find patchy prey. Well, if you think about a colony that size, there's birds basically coming and going all the time. And so they're sort of tracking the location of food around the colony. So if you're on the colony getting ready to go out to try to find food, basically you can just follow the track of the birds coming in, and they'll give you some idea of where it is you need to go to get food. So that's probably a really major, major benefit of colonial breeding. Okay, on the flip side, yeah, there's a lot of potential mates around, but there's also a lot of potential competitors for mates. These same groups that afford a degree of protection may actually attract predators. In a colony that size and that dense, it's easy for parasites and disease to be spread. Suitable colony sites can be few and far between, and they can be long distance from food sources. And then prey depletion. So yeah, there's a lot of birds coming and going, tracking the location of prey, but they're also there before you are and eating. So maybe what they're doing is depleting the prey before you get there. And one of the more compelling demonstrations of this was a paper published in Nature just a few years ago, where they looked at foraging range in northern gannets. So this is quite a large seabird, a large Atlantic seabird, and they looked at the foraging range. So this is foraging range here in relation to the size of the colony. And you can see that there's a very strong positive relationship. So if you're going to nest in a large colony, if you're going to nest in a large colony, you're going to have to go farther to find food. So it's a pretty good demonstration. This is what we call Ashmole's halo, which is the depletion of prey in the vicinity of a colony. Okay, so we talked about the four orders of seabirds, and it's worth pointing out that they're not particularly closely related. So what this tells us is that birds have invaded the sea on multiple occasions in their evolutionary history. And so it's interesting that the same suite of life history attributes have evolved every time birds have invaded the seas. So this tells us that these really are adaptations to life at sea. And so the really defining life history attributes of seabirds are a sort of a live slow, die old lifestyle. So these birds approach things very cautiously. So they want to live a long time, but they're not going to raise a lot of offspring in any one year. So typical is that the birds lay just a single egg clutch per year. These offspring grow slowly because, again, these birds have to go a long way to find food. It's not like a sparrow that can just pop out back and forth, feeding the offspring. These birds go a long way to get food. They come back maybe once, twice, 3 times a day. So their offspring really are going to be growing quite slowly. The third characteristic is that there's generally a period of deferred maturity. So the birds don't start breeding generally until they're somewhere between 3 and 8 years, and then some of the larger albatrosses even quite a bit longer than that. They tend to return to the same site to breed and to maintain the same mates year after year. Males and females share duties generally, and the survival rate tends to be high. So lots of seabirds, 90% of the birds alive in 1 year will be back and alive and breeding in the following year. So you can think that the key here really is you've got to live a long time because you're not going to raise many offspring in any 1 year. So if you want to compare this to, say, like a mallard duck, mallard duck lays 12 eggs. The chicks hatch, they're out of the nest, they're feeding on the water, they grow very quickly. But at the other end of the extreme, a mallard duck isn't likely to live very long at all. Maybe 2 or 3 breeding seasons would be typical. So these are kind of the two continuums, the two ends of the continuum. You can either approach things very slowly, or you can approach things very quickly. Okay, so I've included these little summary slides because I know you're writing a test after this is all over. So as you can probably guess, the questions and the answers will be in these summary slides. Okay, so the true seabirds belong to 4 orders: the Procellariforms, the tube noses, the penguins, the Spiniciforms, the pelicans and boobies and gannets, the Pelicaniforms, and the gulls, the auks, the skuas, the Charadriforms. According to Tony Gaston's ideas about the seabird syndrome, there are 2 ecological characters that define seabirds. They need to travel long distances to find patchy and ephemeral prey, and they breed colonially, and these 2 characteristics underlie the seabird syndrome. And from a life history perspective, we think of these birds as sort of approaching life cautiously. You want to live a long time, so it's all about not over-investing. Make sure you survive, come back to breed the following year, because that's key to the whole thing. Okay, again, this is from Tony's book. Tony looked at the diversity of seabird species in relation to latitude. So you can see here's Greenland, North America, South America, Africa, Europe, in the Atlantic. And so a couple of things showed up from this. First is seabird diversity tends to peak at mid-latitudes. But an even more striking pattern probably, the dark parts of the bars are diving species, and the opaque parts of the bars are surface feeding species. So you can see what really happens is simply that there are no diving species of seabirds, or very few species of diving seabirds at the equator. So any thoughts on why that might be? It probably ultimately has to do with water temperature. So the idea is, that great answer. In warm water, cold-blooded organisms like fish tend to be, much faster, much more able to pursue things. So if you think about the types of fish that really define equatorial waters, well, you think of sharks and things like that. Well, you don't want to be a diving seabird in shark-infested waters. So Tony's idea was that this is just like not a good idea. So the diving species tend to occupy more northerly latitudes. Another thing worth pointing out is equatorial waters also tend to be less productive than higher latitude waters, and that certainly could play a role as well. But as you would expect from this sort of pattern where you get peaks in species diversity at mid-latitudes, BC has a rich seabird fauna, as you would expect from latitude. I would suspect, and maybe Pat can back me up on this, I suspect the pattern would be even more striking in the Pacific, because there are an awful lot of auks, particularly in Alaska at northern latitudes, many, many more than there are in the Pacific. So I suspect the pattern would be even stronger if we were to look at this in the Pacific. Okay, so from that we can guess that waters off the BC coast are important to seabirds. 1989 estimate by my colleague Michael Rodway and Moira Lemon. They visited all of the islands off the BC coast over the course of 6 or 8 summers, and it just did a tally of all the different species and got estimates of population size on all of these islands. Just a monumental job. And their estimate was that BC supports something on the order of about 5.6 million breeding species of 16 species. So, sorry, 5.6 million breeding individuals of 16 species. And in addition to that, we've got huge numbers of birds come up from the Southern Ocean in their non-breeding season. So if you're ever out on the water, anywhere off the coast, you'll see large numbers of shearwaters. You can see albatrosses, all kinds of species that come up from the Southern Ocean. One interesting thing about the BC coast from an oceanographic perspective, so the Japanese current crosses the ocean and hits North America right off our coast, and it splits into a northern current, the Alaska current, which is basically a downwelling system, and the southerly curling current is the California current system, which is an upwelling system. And then a big part of the BC coast is in the transition zone between these two currents. So you might expect from that, as well as just from latitude, that we would have a pretty diverse seabird community, and we do. Okay, so the breeding seabirds of British Columbia, 16 species breed here from 3 orders. Of course, we've got no penguins, but the other 3 orders are covered. So we've got 3 breeding species of Procellariform, the northern fulmar, and then 2 much more common species, leeches and fork-tailed storm petrels. In terms of pelecaniforms, we've got 3 species of cormorants, pelagic cormorant, Brandt's cormorant, and double-crested cormorant. And in terms of charadriforms, we've got 1 breeding species of marine gull, strictly marine gull, that would be the glaucous-winged gull, and then a whole suite of alcids or auks, the common and thick-billed murre, the pigeon guillemot, the ancient merlet, the marble merlet, Cassin's auklet, rhinoceros auklet, and the horned and tufted puffin. Okay, so this is, I mentioned the sort of the habitat diversity in terms of marine systems off our coast. In fact, three of these species are species that we think generally of having more sort of Arctic affinities. The northern fulmar, there's just 3 of these, generally 3 pairs nested out on triangle, and it's the furthest south breeding. I won't call it an aggregation. These 3 pairs are as far south as this species breeds in the Pacific. The horned puffin, there's a handful out on Triangle Island. There's a handful nest in Haida Gwaii archipelago as well, but again, not a very common species at all. And then there's about 20 pairs of thick-billed murres that nest out on Triangle. These are the Arctic congener of the common murre, so it's really a little taste of the Arctic, especially out on Triangle Island. And then we've got 1 species that we think of as having a much more southern affinity, and that's the Brandt's cormorant. So the heart of this species range really is California and Oregon. There's just a handful currently breeding in British Columbia. There used to be more. There are fewer now than there used to be. Okay, but then there's 3 species that really sort of define the seabird fauna of British Columbia. So these are the 3 species that British Columbia supports greater than 50% of the global population. The most abundant seabird breeding in British Columbia is this guy right here, Cassin's auklet. So we looked at a GPS track. This is the bird, this one here. It's about 200 grams, so fairly small, kind of fits in your hand, nice hand warmer when you're banding at night. And this really is the seabird of the Scott Island archipelago. So here's the north end of Vancouver Island. There's Triangle Island, the furthest one out. Triangle Island, I mentioned, supports about 50% of the world population of this species. Sartine Island supports about another 20%, so about 75% of the world population on those 2 islands. And then Beresford also has a pretty large colony. And then there's some decent-sized aggregations up at Frederick Island and the Caroward Islands, but mostly they're just kind of scattered in fairly small colonies. So again, Cassin's auklet really is the seabird of the Scott Islands. Okay, the second species that the BC supports greater than 50% of the world population is this guy right here. This is a rhinoceros auklet, named for the little horn on the top of the bill. This really is the seabird of the Central Coast. So you can see big colonies at Storm Island and big colonies at Storm Island and Pine Island, and then decent-sized colonies up here off the central coast. Klemtu is in here somewhere, I think. In here somewhere. In here somewhere. And then Lucy Island up just off Prince Rupert. And then there's scattered colonies in Haida Gwaii and a sort of a decent-sized colony at Triangle. But again, this really is the colonial seabird of the central coast. And then the third one is really an unusual seabird. This is one species that breaks quite a few of those rules that we've just talked about in terms of seabird ecology. So this is this genus. This is ancient murrelet, and the genus is Synthobaraphis. These are the only precocial seabirds. So these guys, their chicks actually hatch and go to sea within 2 days of hatching. So they lay a 2-egg clutch. So they don't even bother feeding them at the colony. They just take them straight out to sea right after they hatch and raise them there. And this really is the seabird of the Haida Gwaii archipelago. So you can see big colonies at Frederick and lots of scattered colonies all up and down the east coast. Moresby, and then sort of more scattered on the west coast. Yeah, so something like 50 or 55% of the world population of this species nests in Haida Gwaii. Okay, so one thing that really stands out about the abundant seabirds in British Columbia is they all visit the colony at night, so they're nocturnal on the colony, and they nest in burrows. So it's an interesting question. Why should the birds off our coast have these two characteristics? It's not true for birds from Washington South, and it's not really true for birds in Alaska. It just seems to be this quirk about the seabird community in British Columbia. So we'll come back to this a little bit later. So this is, again, that's a rhinoceros auklet, and this would be a burrow. So they just dig these burrows in the ground. They can go 2, 3, sometimes even 4 meters. And then at the back of the burrow, they lay their egg and they raise the chick in there. Okay, so in addition to the breeding species, I mentioned that there were lots of transients that roll through British Columbia during their non-breeding season. Some of them come from the north, like this Sabine gull. Some of them come from the south. Or I guess these ones actually come from the west. These are short-tailed albatrosses. This is a figure from my colleague Ken Morgan, who maintains the pelagic seabird database. So he's got folks on ships of opportunities out doing seabird surveys all along the coast. And so you can see the real densest concentration of these pelagic birds. They really tend to congregate along the west coast of Vancouver Island and then along the west coast of Haida Gwaii, very close to the continental shelf break there. So very rich waters for these birds. Okay, so to summarize this a bit, BC's breeding seabird community includes 16 species from 3 orders, all of the 4 we talked about, less the penguins. Auks are the major taxonomic group, forming 9 of the 16 species. And BC supports over 50% of the world population of 3 auks, and all 3 of them are nocturnal burrow nesting species. The Cassin's auklet, which is the really defining seabird of the Scott Islands, the rhinoceros auklet, which you kind of think of as the Central Coast colonial seabird, and the ancient murrelet, which you kind of think of as the Haida Gwaii colonial seabird. And in addition, we get huge numbers of transients, both from the north and from the south, during their non-breeding seasons. Okay, so then I wanted to describe some of the research we've been doing at Environment Canada. Well, most of the research I've been involved with over the last 15 years or so. And so the point or the aim of the research that Environment Canada does on marine birds is to understand the environmental and demographic causes of population change. So we're trying to understand how many seabirds are out there, why are there that many seabirds out there, and if there are any sort of changes, what's causing the changes, so that we can manage these species effectively. So this is kind of the flow chart I use for my research program. So again, ultimately, we're trying to determine population trends. And population trends can be stable, population trends can be increasing, or population trends can be decreasing. But they don't just change for no reason. They change for a reason. And when there's change, you can understand or you can know that there's some sort of environmental or external driver that's changing the demography. So that's the balance between births and deaths in the population, and then that's leading to the change in population size. So essentially our research is trying to link environment to demography and demography to population trend. Okay, so I just wanted to go through a few examples of the sort of things we're doing. And the first one has to do with the environmental control of demography in Cassin's auklets. And this was an idea that my colleague Doug Bertram first formulated, and he formulated long before he really had the data to test it. So it's really kudos to Doug for how strongly his ideas really have panned out. And it has to do with the relationship between the timing of the peak availability of this critter here. This is a Neocalinus copepod. So it's a lipid-rich, abundant, large copepod, fabulous food for these Cassin's auklets, which are zooplanktivorous. And it has to do with the relationship between the time in the season when these things are available to the birds and the time when they're raising their chick. So this is a little Cassin's auklet chick. And so the idea is the birds can be matched temporally with their prey, or they can be mismatched with their prey. Being matched obviously is good, being mismatched is not good. And Doug thought this might have to do with ocean temperature, because the zooplankton folks know that there's a very strong relationship between the timing when these guys are available in the season and ocean temperature. And then Doug thought, well, that would probably have important effects on the birds. So the idea is this. This is a schematic of the life cycle of one of these copepods. And this is sort of the surface of the ocean here and depth. And so the cycle starts at depth in the fall when these things lay their eggs. And then the eggs hatch sometime early, or sort of earlier midwinter. And then the young copepods make their way up into surface waters to feed and grow. And then when they're all fat and happy and everything's good, they pop back down. But of course, this isn't carved in stone, or it's not set by calendar date. It's set by ocean temperature. And the idea is, in years where the ocean is warm, the time when these things are up here in the surface water tends to be early, and it tends to be narrow. Whereas in years where the ocean is cold, these things will tend to be up in the surface water a little bit later, and they'll tend to stay a little bit longer. So Doug's idea was that the birds would be mismatched with this prey in warm water years, but matched with this prey in cold water years. Okay, so since we've been running the program on triangle since 1994, and this chart goes up to 2010, this is sea surface temperature anomaly on the y-axis here. And the 0 is the long-term average. So this is the average in the period from 1930 to 1993. So any year where the bar is above the long-term mean, we can think of that as a warm year. Where it's sort of at or below, we can think of average to cold, warm again, and then average to cold. So you can see in the period between 94 and 2009, we had a warm period through 1998, then a fairly cold period through 2002, then back to a warm period from 2003 to 2006, and then back to a cold period from 2007 to 2009. So it really gave us a perfect opportunity to test Doug's idea about the effects of ocean temperature on the prey, and then effects up to the birds. Okay, so what we've done is we go out on 5 occasions in the summer, starting on 18th of May and going to the 27th of June. And this really is the peak time when the birds are out there trying to raise chicks. And what we do is we intercept 10 birds on each of these occasions. We collect a little bit of food from them, so they come in with they've got a pouch that develops during the breeding season. They load it up with zooplankton. They come in and then they feed the chick stuff from out of that pouch. So we intercept them on the way in, intercept a little bit of the food, and then send them on their way to feed the chick. And then we send this off to scientist at Institute of Ocean Sciences, and she tells us what's in the food items. So here we've got what proportion of the diet on each of these dates is composed of this copepod, this orange copepod, Neocalnus cristatus. And I know it's a bit of a busy figure, but what you need to know is that the years with the dark circles or the dark upside down triangles are warm water years, and the ones with the open symbols are cold water years. So you can see, just as Doug predicted, in the warm water years, there's lots of Neocalnus cristatus available to the birds early in the season, but then it completely drops out of diets in the second half of June. Whereas in the cold water years, it remains highly abundant in the diets right through the summer. So that's exactly what Doug would have predicted about the effect of ocean temperature on the diet in these birds. And then this has important consequences for the birds. So here again is our Cassin's auklet chicks. This figure out here, we're looking at the proportion of this copepod that the chicks receive in their diet over the course of the summer. Here we're looking at the percentage of the chicks that survive, and you can see there's a strong effect. So the birds survive at a much lower rate when they get less of this copepod in their diet than they do when they get a lot of this copepod in their diet. And there's a very similar effect here on fledgling mass. So not just what proportion of these nestlings survive the year, but how heavy are they at the time they complete development and go off and start an independent life at sea. So it's the same sort of effect. Each one of these points represents a year, and you can see these years where they're getting something like 50% or more of this copepod in their diet. They're going to be much fatter, much healthier, and much happier when the chicks leave and go out to sea. So there's a very strong effect of ocean temperature on breeding success in these birds, and it has to do with this relationship between when they're raising chicks and when this copepod is available to the birds to feed to their chicks. Okay, so we mentioned that demography is this balance between births and deaths. So we've just looked at how environment affects the birth side of the equation for Cassin's auklet. What about the survival side of the equation? This is my former grad student, Kyle. And Kyle took a data set on collected from banding Cassin's auklets. We started that project in 1995, and we're still continuing it. But Kyle analyzed data through 2007, 2008. So basically, we're asking the question, what proportion of the birds that are alive in one year come back to breed, are still alive and come back to breed in the following year? And for Cassin's auklet, Kyle got some rather stunning results. I can tell you I was stunned when I saw this. So the first thing, because we can sex these birds from external measurements, he was able to separate the banded birds into males and females. And this was a data set of several thousand birds, so it was a very comprehensive data set. So he found two things. First of all, the hypothesis he was testing was that these extreme years, like the 1998 El Nino event, which is a very strong ocean anomaly event, and another strong ocean anomaly event in 2005. Both of these we know greatly reduce zooplankton abundance in the area around Triangle Island. So the questions he was asking was, are these ocean anomalies, do they have effects on the survival rates of the birds? Okay, so the first thing to notice is that, again, we're looking at about a 13-year data set. The survival rates of the females in most of these years tended to be something about, I think it was about 87%. So 87% of the female Cassin's auklets that are alive this year will be back in breeding next year in these sort of typical years. For males, the percentage was quite a bit lower. I think it was almost 10 points lower. Yeah, so the male survival rate was just a shade under 80%, and it wasn't affected by these really strong ocean anomalies. The background survival rate, or the survival rate of females in normal years, was about 10 points higher. But when we hit these anomalous events, you can see the survival rate of the females was cut in half. So it dropped from high 80s to sort of mid to low 40s. So basically, half the females that were alive in 1998, died in that winter and were not back to breed in 1999. But there was no suggestion of this sort of effect in males. And same thing happened again during this extreme year, where half the females alive in 2004 did not come back to breed in 2005. So there's two questions here. The first is, why is the background or the normal survival rate of female Cassin's auklets much higher than the background survival rate of males? And it's 10 points. It may not look like much, but if you sort of play it out in terms of life expectancy, it means that if a female only experienced these kinds of years and a male only experienced the same kind of years, you could expect a female to live twice as long. But then we have these anomalous events where the males are barely affected and half of the females go out to die. So there's two questions. Of course, why is the background survival rate of the females higher than the males? And why is it only females that are affected by these anomalous events? And sadly, we don't have the answer to either question at this point. But we are working on it, and we do have some ideas. Okay, so there's a species where sea surface temperature, ocean temperature, has a very strong effect on breeding. Here's another one. This is what's called a black oyster catcher, and it's a shorebird. It's not a seabird, but I kind of think of it as an honorary seabird because these are birds that are obligate marine feeders. They spend their entire life cycle right on the seashore feeding in the intertidal zone. So I kind of think of them as an honorary seabird. And so we've been keeping track of breeding populations of this species on Triangle Island. So this is what their nest looks like. They just dig out a little nest bowl in the gravel, usually line it with shells from mussels and limpets and things like that, and then they just lay a clutch of 1 to 3 eggs right in there. So it's a simple matter to keep track of the number of nests. The other thing is they tend to live a long time, another characteristic they share with seabirds, and they tend to nest in exactly the same spot from 1 year to the next. So again, these are characteristics of marine birds. So this is Triangle Island, a map. Our camp is right up in here. And each of these black dots is the location of one of these black oyster catcher nests. So we've been keeping track of these nests since 2002 now, and we just we measure the number of eggs, we measure the eggs, we keep track of the fates of the eggs and the chicks. And we've been doing this now for quite a few years. And a couple of years ago, my colleague Bob Elner and I decided we would have a look at see if there was anything in these data, because there was all kinds of information coming out that sea surface temperature has strong effects on things that these birds like to eat, like mussels and limpets. And so we got to wondering whether this was having any sort of demographic consequences for these birds. And so when we plotted the number of nests against the sea surface temperature, you can see these were on the same stretches of beaches on Triangle. Anytime the ocean was less than about 9 degrees Celsius, this was, I think, March sea surface temperature, we got either 14 or 15 nests. But in the years where the ocean was warmer than 9 degrees, we only got somewhere between 9 and 11 nests. So here's another species where there's an effect of ocean temperature on productivity in the birds. We're not sure what exactly is causing this, but we suspect it's probably got to do with the nutritional value of the types of things like mussels and limpets that they like to eat, or it might have something to do with the behavior of these things. Maybe the mussels are a little bit faster to react to the presence of birds, and the birds aren't quite as successful at depredating them when the water is warm. Or another possibility is that the limpets may be able to grip the rocks a little bit more tightly when the water is warm, and so the birds can't knock them off as easily. So we're intending to follow this up to get some idea of what's actually going on here. Okay, and then for a lot of years we were kind of working on the assumption that ocean temperature was an important factor driving breeding success in rhinoceros auklet, again named for the horn on the top of the bill. So we had a pretty strong effect where sea surface temperature in the spring, this is how successfully the birds breed. So you can see in general, there's a tendency for the birds to breed more successfully in years where the ocean is cold and to breed less successfully in years where the ocean is warm. So this was exactly what we were seeing with Cassin's auklet. We were pretty satisfied with ourselves that this was the same kind of effect operating in the rhinoceros auklets. And then in 2007, this happened. And so it was a cold ocean year. We would have expected the birds to have a very good year, but in fact, the birds had the worst year in the time series. And so there was some data available to us that went back to as far as the 1970s. And when we went back and had a look at those data, we noticed that the same thing had happened one other time in 1976, where we had a cold ocean, but the rhinoceros auklets had a terrible year. So it happens once, maybe you put it down to a fluke, but it happens twice and it makes you think, okay, there's something else going on here. So in other words, this correlation, we became pretty sure was just correlation and not causation, and that it could be overridden by some sort of other environmental factors. Okay, so just about this time, there were some folks over at the Institute of Ocean Sciences with the Department of Fisheries and Oceans, and they were doing some work on timing, the effects of variation in timing of the spring bloom on marine predators. And they were looking at data sets on fish. And they weren't really very happy with the results they were getting, so Bill Crawford called and said, hey, can we have a look at your bird data? To see if when we overlap this on this chlorophyll data, if anything shows up. So that's how this all got started, and it turned out to be a really pretty nice story. So anybody who sails will probably know that the predominant winds off our coast in winter tend to be from the southeast, and the predominant winds in summer tend to be from the northwest. And so we get this transition from these southeast winter winds to the northwest summer winds, sometime generally in the month of April, can occur as early as late March and as early as late March and as late as early May, but generally it happens sometime in the month of April. And it's important when it happens because these southeast winds in the winter tend to create downwelling conditions along our coast. So downwelling is a process whereby nutrients essentially are sucked down to the bottom of the ocean and not available to things up at the surface of the ocean. Whereas the northwest winds that we get in summer tend to create upwelling conditions along the coast. So upwelling is a process that brings nutrients from ocean depths up to the surface. This transition happens in the summer, so suddenly we've got nutrients coming into surface waters just at the time where the amount of solar radiation is increasing, and so this results in the primary productivity, or what we sort of commonly call the spring bloom. So this transition, when it occurs, is important because it affects the timing of the spring bloom, which of course kind of sets everything in motion for the entire year. Okay, so we looked at data from 1998 to 2008 because these were the years, starting in 1998, where there was satellite imagery available. So this is the north end of Vancouver Island here. There's the BC mainland coast, and these are just satellite images. So the really colorful areas are areas where there's a lot of primary production going on, so a lot of phytoplankton. The blue areas are areas where there's just nothing much happening at all. And these are averaged, all of these maps, or all these images are averaged over the month of April. So you get an idea that in some years, there's really strong primary production in the month of April. Some of the good years would have been 2001, 2002, these really colorful maps. 2000 was pretty good, 99 was good, 98 not so good, 2003 not so good, 2006 not too good, 2005 not too good, at least around Triangle. But the two I would sort of draw your attention to are 2008 and 2007. So 2007, basically in the month of April, the ocean is a dead zone. 2008, there's tons and tons of primary production out here around the Scott Islands. So very poor year for primary production in the month of April in 2007. Very good, very strong primary production around Triangle Island in 2008. Okay, so what are the consequences here? Okay, so on the y-axis again, we've got, this is a measure of how productive the birds, how strong their breeding is in a given year. And this is the mean April chlorophyll. So data obtained from those maps we just looked at within about 50 kilometers of the colony of Triangle Island. So how strong, this basically you can think of this as how strong is primary production around Triangle Island in the month of April. And so you can see when primary production is strong around Triangle in April, the birds tend to breed much more successfully. When primary production is weak in April, the birds have a very poor year. And it's really a remarkably strong correlation. And this one, unlike the sea surface temperature, we're pretty convinced is correlation, or sorry, is causation and not correlation. And the reason is because in the same way that those Cassin's auklets really rely on Neocalnus cristatus to breed successfully, those large copepods, the rhinoceros auklets really depend on this species. This is a sand lance, which is a small forage fish, sort of about that size. They hatch out in the spring and they move up into surface waters and they feed and grow there, and the birds get them when they're up there feeding. And so these things hatch out in the month of April. So if there's strong production, strong primary production, the sand lance, so if there's strong primary production in the month of April, the sand lance will experience good feeding conditions. Survival of that year's cohort of sand lance will be good. The growth of that cohort of sand lance will be good. And so there'll be lots of food available to the rhinoceros auklets. So this is that same chlorophyll in the month of April. And this is what percentage of the diet is composed of sand lance. These are for the birds on Triangle. So you can see when the chlorophyll, when the primary production is weak, the birds don't have access to very much sand lance. When primary production is strong, they have access to much more sand lance. So again, we think this is the real driver. They really are very much dependent on sand lance to raise chicks. Okay, so back to Kyle's analysis, looking at survival rates of rhinoceros auklets. Remember the two things about the Cassins were that there was a pretty strong difference between male and female survival rates, and there was a very strong effect of those ocean anomalies on the survival rate. Well, when Kyle modeled the same question for rhinoceros auklet, what he found was there was no difference in survival rates between the sexes, and there was no effect of those extreme events. So even two species of seabirds breeding on the same colony can be very differently affected by variation in environmental conditions. In this case, these birds survive at about a 90% rate. So 90% of the birds alive in 1 year will be back to breed the following year. Although I will also mention, my colleague Moira Lemon banded some rhinoceros auklets out on Pine Island, which is sort of the other side of the north end of Vancouver Island towards the mainland. She banded just a handful of birds, I think 12 or 15 rhinoceros auklets in 1984. And they were already breeding adults in 84. And we recaught those birds in 2010, both still breeding. So probably those birds were well into their 30s, maybe into their 40s. So one thing about seabirds generally is some individuals, like all of the birds tend to survive at a pretty high rate, but some individuals tend to be unusually successful. And those are the birds that really go on to populate the next generation. So you get ridiculous skews, like 20% of the birds produce 80% of the offspring in the following generation, things like that. So some birds are unusually successful, even as you get a figure that looks like this, where it looks like everybody survives at a high rate. Okay, so what we've talked about up to now is what's called bottom-up control. So how do events at lower trophic levels affect predators? And that's really been the main focus in seabird research for, well, basically forever. And this sort of top-down effects, so these are how do predators affect population processes in seabirds, really has not received very much attention at all. I mean, it's kind of shocking to think about it, but it's true. But over the last few years out on Triangle Island, we've had a really stellar demonstration of just how strong the top-down effects of predators can be on seabirds. So I just wanted to tell you this story. And it has to do with common murre. So there's a common murre on Triangle holding one of these sand lance that we were talking about, just about to feed its chick here. So it has to do with common murres and bald eagles, and then we'll see some sort of intermediary players as well. Okay, so this got started when in 2004 I thought we should probably do a survey of all common murres in British Columbia, just to get a sense of what was going on with populations, because there was concern about birds being killed in, particularly in salmon gill nests in Johnstone Strait. So we thought we should probably get some idea of whether this was having any sort of population level effects. So we did a complete survey of all known common murre colonies in British Columbia. So there was a group out at the Carraward Islands, group here at Sartine Island, a group at Triangle Island, and then a couple of sort of strange breeding records of 1, 2, 3 birds at Clayland Island in Clayoquot Sound, at Florencia Island, and at Starlife Reef. So we went back and we resurveyed all of those colonies in 2004. These weren't active. Sartine wasn't active, Carraward Islands was, but it was really these colonies around Triangle where we noticed that something strange had been going on. So the only previous survey had been done in 1989 by Michael Rodway. And so this is the dark bars here are the results of Michael's 1989 survey, and the opaque, the clear bars are the results of our survey in 2003. So you can see in 1989, so we're looking at the area around Triangle Island. So on Michael's survey, he found that there were about, I can't remember what the number was exactly, 4,000, I think, murres breeding on Puffin Rock, something like 500 breeding at Southeast Point, something like 1,000 at Murre Rock, another 1,000 at Castle Rock, and then 600 breeding at Triangle Island, for a total here of about 6,500 murres. When we did our survey in 2003, there were more birds at Puffin Rock, about 4,500, but there were no birds breeding at any of these other sites. So there was 2 interesting things here. First of all, our total was quite a bit bigger, so there were many fewer common murres nesting in British Columbia in 2003 and 1989. But even more striking is that they had abandoned these sort of small satellite colonies, and they had all aggregated to breed at Puffin Rock. So we got to wondering what was going on. Okay, so here's a picture of the common murre colony at Triangle. And another thing to note is when Michael did his survey, the birds were out on these rocky areas here. And there were still lots of birds there, and in fact more than there were when Michael did his surveys. But you can see some of these other little groups here. And the thing to notice is that these birds are nesting not on bare rock, which is normal for murres. They're nesting on dirt. So that tells us that these are newly colonized areas, because over time the bird's guano and the birds just sort of tramping around and stuff like that, will wear this down to bare rock. So what this told us was, okay, the birds had aggregated, they had formed, they started like colonizing new parts of the area on Puffin Rock here. So clearly something was drawing these birds into Puffin Rock and away from those satellite colonies. Okay, so a little bit of detective work was required. So we went back and looked at some of those reports from the 1980s and the 1970s. And one thing people like Keith Vermeer and Michael Rodway had said consistently was that the murres were not breeding successfully on Triangle Island. That what they would find were large numbers of murre eggs, usually around glaucous-winged gull nests. They would see the gulls feeding on the murres. So something clearly was preventing the murres from breeding successfully. And what they proposed was that it was predation by bald eagles. And not just predation by bald eagles, but this is that same rock. That's this rock here. And in fact, it looked like this, like 2 minutes before this happened. What happened was a bald eagle came up around over the top. The murres just panicked and flushed off the rock. The eagle grabbed the common murre. All the murre's eggs are now exposed, and then the gulls come in and take the murre's eggs. And so that's what they were reporting back in the 1980s. So the question was, okay, well, what's happened that suddenly the murres are able to breed successfully? Something was going on. And so what actually had happened was that a pair of peregrine falcons had set up an eyrie right in the middle of that group of breeding murres on Triangle Island, on Puffin Rock. And peregrine falcons do not like bald eagles, and they defend their nests very aggressively. And in fact, there are even accounts of peregrine falcons killing bald eagles. So this was the male of the pair, and he used to just sit up on that perch, that rock there, and he would just spend his days there. The eagles would never fly over while he was there because he would get up and chase them off. Then when they needed some food, he would just fly out over the ocean, come back with a Cassin's auklet, feed it to his mate, and then go back and sit on his perch. So this one falcon basically created what we started calling this umbrella of security for the murres. So here's a schematic of Puffin Rock. The murre colony is the dark area in here. The falcon eyrie was right in here. And if you read the literature, they'll tell you that the falcons generally defend an area of about 100 meters around their nest. So basically, these murres had all packed in into the vicinity of this falcon eyrie. The falcon kept them safe from the eagles, and so suddenly we had one of the most productive murre colonies in the North Pacific. So things changed completely when this pair of peregrine falcons established their eyrie. Okay, so yeah, while the falcons were there, they kept the murres away from the colony on Puffin Rock. Okay, but then there was a change. So things looked good, 2003, 2004, 2005, 2006. We never saw any episodes of eagles flying over the murre colony because that falcon was there preventing the eagles from flying over. We never saw any instances of eagles depredating murres off the colony, and we never saw any instances of what we call facilitation, which is the event that happens when the eagles chase the murres off and then the gulls come in and feed on the eggs. We say that the eagles were facilitating predation on murre eggs by the gulls. But then there was a change in 2007. One of the falcons showed up that year, but the pair didn't breed. And so we started noticing, well, there were a couple of episodes where we saw eagles flying over the colony. We didn't witness any depredations, but we did witness some episodes of eagles facilitating predation by gulls on the murre eggs. And then in 2008, all hell broke loose because there were no falcons around at all. And so suddenly we were back to a situation where the eagles just had free run of the murres on the colony. So there were eagles flying over all the time. We witnessed quite a few depredation events, and the gulls were having access the entire summer to murre eggs. So things changed completely between 2006 and 2008, just because that pair of falcons no longer bred above the murre colony. And so suddenly, if we look at production, so this is the proportion of common murre pairs that were able to raise chicks in those years. You can see when the falcons were present, they were pretty successful, about 70% typically, 70-80% of the birds managed to raise chicks. In the year when there was only one falcon present, production dropped off a little bit. And starting in 2008, we have had zero production off the murre colony since. So it's a pretty astounding example of how predators can actually control productivity in seabirds, and it's not something that gets widely recognized. Okay, and then we talked about how initially the murres were in those satellite colonies around Puffin Rock. Well, after the falcon pair disappeared, the big aggregation on Puffin Rock started breaking up, and we started seeing these smaller aggregations forming all around the island. So it's sort of the reverse behavioral process, all driven by presence-absence of falcons. Okay, so we started, well, quite a bit earlier. We asked the question, what is it about seabirds in British Columbia? Why do they all visit the colony at night, and why do they all nest in burrows? And I think probably the answer is because of the density of bald eagles. So open nesting species like murres and cormorants just really have a hard time coexisting with eagles. And so the idea that nocturnality and burrow nesting are anti-predation behaviors, I think probably tells us why our seabird fauna is so heavily dominated by birds with these characteristics. Okay, so quick summary. Oceanographic variation has dramatic effects on the food webs that support BC seabirds. The two examples we went through were the Cassin's auklets are mismatched with their most important copepod prey in warm water years, so they breed less successfully in warm water years, they breed more successfully in cold water years. And in much the same sort of way, a strong and early spring bloom leads to higher recruitment of Pacific sandlats, and that creates better feeding conditions for breeding rhinoceros auklets in the province. And predators can limit seabird productivity through top-down effects, and it's not something that gets widely considered. Would now be a good time for a break? Okay, so I think Jonathan wants to take a 10-minute break, 15-minute break? 10 minutes. Okay, sounds good. Okay, no worries.
Really great story. It's amazing that one or two birds can have such a huge impact on an entire colony. 10, 20, 30,000 birds? So whenever you're done, and then
Okay, so I think we're pretty close to done. There's just one last section to go here, and has to do with conservation issues for seabirds in Canada. This is a dovekie, so this is a small North Atlantic seabird. This individual washed up on a beach in Newfoundland. You can see there's a little spot of oil on it, and the bird would have died of hypothermia as a result of just that small amount of oil on it. So just to give you some idea of how vulnerable these birds are to oil. Okay, so what we would consider to be the main conservation issues for seabirds in Canada, and this is true in British Columbia, climate change, oiling at sea, which includes both chronic oiling, so that's sort of the small scale discharging of oil from fishing boats and that sort of thing. Then there's the sort of catastrophic events, so think Exxon Valdez, fisheries practices, habitat loss, and introduced predators, so that's predators that don't belong on seabird islands, but they were introduced. Often rats are introduced in shipwrecks and things like that. And then what I'm going to call native invaders. Okay, so the first one to consider is climate change. And we talked about how ocean temperature and extreme climate events can affect population processes in Cassin's auklets. So recall that they breed less successfully when the ocean is warm, and that the survival of adult females is cut in half during extreme climate events like strong El Niños and things like that. Okay, well, what the climate modelers are telling us is that we can expect the ocean to continue to warm. In fact, I think this year, starting, I think, late spring 2014, the North Pacific is warmer than it has ever been recorded. And they're expecting that this is going to continue on probably through the winter. So climate modelers tell us we can expect the ocean to continue to warm, and we can expect these extreme climate events to happen with increased frequency. So the implications for Cassin's auklets are pretty dire. If that plays out as the modelers tell us we can expect it to. And so this species is being assessed by the Committee on the Status of Endangered Wildlife in Canada now for listing. We would like to get them listed under the Species at Risk Act. Still very abundant seabird. There's lots of them around, but just based on what the climate modelers are telling us, we think that there's reason to be concerned about the future for this species. Okay, big issue. Some places, especially off the East Coast, you may recall about 10 years ago, in fact more than 10 years, probably 15 years ago, there was an estimate made that something like 300,000 seabirds were being killed annually off the east coast of Newfoundland as a result of oiling. We think that problem has been lessened, the severity of that problem. But one thing about Newfoundland is because of the currents, birds that die at sea will tend to wash up on beaches on the east side of Newfoundland. So you get a pretty good idea of the numbers of birds that are dying at sea and washing up because they can recover oil carcasses and things like that. I showed you the photo of the dovekie from Newfoundland. Well, it's an entirely different situation in British Columbia because the currents do not tend to carry items into land. They tend often to carry them either south, north, or out to sea. So we don't really have a good idea of the extent of the problem in British Columbia. We don't think there's a major problem, but it's really hard to get a very good assessment of that. But this figure here just shows the density of shipping traffic off our coast. So there are an awful lot of vessels of various size transiting off the coast. So there's always the possibility for chronic oiling, and there's possibility for at least small scale, more major events. Okay, so as you can probably imagine, a lot of the work I've been doing in the last few years has been related to environmental assessments around things like the Enbridge, proposed Enbridge pipeline, the proposed Kinder Morgan pipeline is probably going to be a big part of my job in the next couple of years. So I just wanted to give you some idea of the sort of work we're doing around these environmental assessments related, in this case, to the Enbridge proposal. Okay, this is a Barrow's goldeneye. It's not a seabird, but I just wanted to tell you some of the work that my colleague Sean Boyd has been doing. So one of the keys around this environmental assessment is we want to get a sense of what marine birds are up there in particular off the central coast, when they're there, why they're there. So Sean, last summer, this is his co-worker Malcolm, who's a veterinarian. He implanted satellite tags into a bunch of these birds, and then they recover in about 5 minutes, and off they go, and they're carrying a little device about this size inside their body cavity, and for some reason it doesn't seem to bother these sea ducks at all. So they implanted a bunch of these devices in Douglas Channel, so just off Kitimat, just to see where the birds were going, when they were back, if they were coming back. And so you can see all the birds were tagged in here. They dispersed all over the Northwest Territories. They're all now back on the coast. One of the birds, I think Sean said, is currently sitting just off Los Angeles somewhere. But most of the birds are back around the coast here where they were tagged. So we think these birds are probably fairly strongly attached to this area. So it's an important area for sea ducks. So that's one thing we've learned. I mentioned that the rhinoceros auklet, this guy here with the little horn, is kind of the seabird of the Central Coast. So most of my work has been involved with learning more about habitat use in this species. So we've been working on Pine Island, a little bit of work on Triangle Island, on Moore Island here off the Central Coast, Lucy Island, and at Skungwai. And we're doing similar sorts of things to what Sean's doing, although using different types of devices because we cannot implant these birds because they dive so deep. You can't open up the body cavity and expect that the bird is going to survive in the long term. But one of the first things we did was to just have a look at genetic variation. And this is a valuable thing to do because it gives you some idea of the way the larger population operates. And so this figure over here is a result. So we got some birds with some bird blood. Just like you prick the vein, collect some buds, and you can use that to do the DNA, the genetics work. So we collected blood from, well, actually our colleagues in Japan collected blood from birds on Turi Island. We collected blood on Triangle Island, and then colleagues in Alaska collected blood from birds on Joviet and St. Lazaria and Middleton, and then we covered our 5 BC colonies. And the way to read this figure, and I'm not going to claim that I understand it, but basically the farther apart 2 points are, the more genetically dissimilar they are. Okay, so no surprise that the rhinoceros auklets in Japan are substantially different than any of the birds in North America. But the real surprise to us was that the birds on Triangle Island were actually genetically distinct from these other birds, these other populations in British Columbia and Alaska. So what it tells us is that all of these rhinoceros auklets here probably are essentially operating as a single population, what's called a metapopulation, what ecologists call a metapopulation, along with the birds in Alaska. Why the birds on Triangle should be distinct genetically from the birds on Pine, we don't know, but we're going to do some more work this year because we think what's happening is that there's a California current genotype and then there's an Alaska current genotype. So maybe the birds at Triangle just head south, which in fact we know they do, and maybe the birds on these other colonies, even though it's just a hop, skip, and a jump from Triangle to Pine, these birds probably spend winter somewhere else. And so these two populations, larger populations, never mingle. And so they're genetically distinct. And this is important information when you think about management because it tells us, again, that this group probably is basically all operating as one population, and then there's a separate population here. So in terms of vulnerability to oil spills, potential for recovery, this is really good, important information to have. Okay, so what we're doing is we're using those GPS tags. So we looked at a Cassin's auklet GPS track a little bit earlier. We deployed on rhinoceros auklets on all of the major colonies as well because we want to locate important for feeding areas for these birds around these colonies. So here again is a track for a rhinoceros auklet that we deployed a GPS tag on Triangle. This one, let's see here, we deployed at about 1:30 in the morning. The bird left the colony at about 3:40 in the morning, sat on the water just off Triangle till about 4 o'clock, then headed southwest. Did a lot of traveling between 4:45 and 5 o'clock, and again between 6 o'clock and 6:30 in the morning. The maximum extent out here was about 120 kilometers off the colony, so this bird was out here about 120 kilometers away by late morning. Again, talking about the long distances that these birds travel. Stayed out here and fed until about 8:30 at night, then started making its way back to Triangle, was sitting on the water just off the colony at 11:30, came in to feed its chick at about 12:15, and then left again the next morning and did this track. So we got about another half day before the battery died on the GPS unit. So we're hoping to do this again probably for the next 2 years, the idea being that we'll locate areas that are really important to these birds, which would help with directing shipping lanes and things like that. And then the second type of device we're using is this right here. This is a rhinoceros auklet in a bird bag. My grad student Katie has just deployed one of these GLS devices on this bird. So it's the same thing. You catch them on their way out in the morning, slap the tag on, set the bird on its way, and it comes back, it just continues on with its breeding. What these ones do is they're reading light levels. So these are on the bird for basically a year. And so you retrieve the bird the following year, you download the data that's been picked up on the device, and it gives you a track of where that bird has been over the course of that year. It's really, it's absolutely mind-blowing stuff. But because we just deployed these this year, I don't actually have any tracks for a rhinoceros auklet, but we did get some tracks for Cassin's auklets a couple of years ago, and here's what they look like. So up here, this was a bird that one of these devices was deployed on Triangle Island in 2010. Initially, the bird went north up into the Gulf of Alaska, spent a long time up there, then made a very, very quick trip down and spent the rest of the winter off, mostly off California, off Baja, even further south off Mexico, and then made its way back to the colony and was back in the breeding site I think it was April the 3rd the following year. And then these birds, these other ones, we deployed on Frederick Island, which is in Haida Gwaii, but it's the same thing, basically. Well, this guy here went almost to Hawaii, but same sort of pattern generally, where they initially disperse north, then make their way down. This guy was a bit unusual. These two did something not too dissimilar from what the bird on Triangle did. So they spent the winter off California, which seems like a pretty sensible thing to do, and then back to the breeding colony the following spring. So we're hoping to get all kinds of these sorts of tracks for rhinoceros auklets. In fact, we deployed on a total of 10 colonies this summer, spread from Alaska to California. Okay, this is a busy figure, and I really hesitated to put this one in, but there's an important message here in terms of fisheries practices, and in particular, the effect of fisheries practices, the effects they can have on forage fish populations. So this was a paper published in Science just a couple of years ago. The way to read these figures, you'll see there's 7 of them, and you'll see that they come from seabird locations basically all over the world. But they're standardized in such a way that they're directly comparable. And so on this axis, this is an index of the abundance of the critical forage prey species for the bird. And on the y-axis, this is an indication of how successfully they bred. So the basic message here is, I mean, it's remarkably similar across all of these colonies. And that's that when forage fish are abundant, everything is fine. But when you get to about 1/3 of maximum forage fish abundance, productivity of the birds really starts dropping off. And it was basically exactly the same pattern at seabird colonies all over the world. And so they actually titled their paper something about 1/3 for the birds. So the message here is that these birds need abundant forage fish populations in order to breed successfully. Their population processes depend on it. So anything that reduces forage fish abundance below this critical threshold is likely to seriously impact seabird populations. And there was a very good example, especially from the North Sea, where there was a large sand lance fishery, not the same sand lance we get off our coast, but a very closely related species. And while that fishery was operating, it actually did have quite serious effects on seabird populations. And so they needed to have that information in order to more effectively manage the fishery. Okay, so here's another sort of busy figure that I kind of hesitated to put in. But this is a paper that's just been published, and it has to do with winter seabird populations in the Salish Sea. So I wanted to include as much BC information as I could. So what they were doing was they were looking at seabird populations in the Salish Sea in the winter, and it's been widely reported a couple of times in the last few years that some seabird populations in the Salish Sea seem to be in decline. And so they went through an exercise of looking at what are the characteristics of the species that tend to be declining versus tend to be increasing. And the two big ones were that they noticed that the species that tended to be declining were diving species, and that they tend to be species that fed on forage fish. Surface feeding species were much less affected, so you can see the bars are much bigger over here for the diving species than for the surface species. But in particular, it's these diving forage fish species that seem to be especially affected. And so they kind of proposed the idea that this may be related to the operation of herring fisheries in the Salish Sea. Certainly in Puget Sound, there's good information to suggest that herring populations have declined along with the birds. But I think, their main message was simply, okay, there seems to be something going on with forage fish, feeders, and diving species. We need more research to get to the bottom of this. Okay, another way fishing practices can affect seabird populations is through seabird bycatch. So these are, these are rhinoceros auklets, and these, I think there's 46 birds. I got this photo from Ken Morgan. These 46 rhinoceros auklets were all killed in a single set of a gill net, a salmon gill net in Johnstone Strait in the mid-1980s. So, yeah, not a good situation. So over the last few years, while we're working on all these colonies, another thing we have been doing is to try to get an assessment of how populations generally are faring, to see if there's any suggestion that populations may be being impacted by fisheries bycatch. But so far it looks like episodes like this they're regrettable episodes, but they're not, this sort of mortality as it's occurring now is not something that's compromising seabird populations here. Okay, so we can kind of flip this around a little bit and ask about what effect the seabird consumption by seabirds might have on fish populations. And this is a research program we got started on in 2012. Some of you might recall the Cohen Commission report, which seemed to, well, it was there and then it was gone. It seemed like nothing really much was done with it, which is too bad because it was a pretty sensible report. And they were trying to get to the cause of declines, particularly in Fraser River sockeye. And one of the things Judge Cohen said was that there's basically no information on predation on salmon once they leave the river, and that this was a large black box. And in order to understand what was going on with populations, it would be necessary to get some idea of causes of mortality once birds hit the ocean, and in particular the role of predators. Okay, so from years of work, we had a pretty good idea that here's a rhinoceros auklet on, I think that was on Lucy Island, and he's got 5 pink salmon smolts in its bill, and he's just on his way in to feed his chick. And so we know these birds eat salmon, but we wanted to get some idea of the magnitude of this in order to understand what kind of effects this might be having on salmon generally, and particularly on Fraser sockeye. So we've been looking at diets in these birds. Well, there's Triangle, there's Pine Island, there's Lucy Island. So Triangle Island and Scott Islands, Pine Island just off the east coast of Vancouver Island, the northeast coast, and Lucy Island up near Prince Rupert. So you can see salmon not terribly common. It shows up usually in something like 20% of the meals that these birds come to feed. Come in to feed their chicks with, but there was this huge spike in 2012, and those were basically all Fraser sockeye, as it turned out, from the genetics work done by the DFO. And so you may recall that we had that huge run up the Fraser in 2010, so that would basically be the offspring from that big run. Historically, there hasn't really been that much salmon in diets at Pine, but over the last few years we've seen quite a bit more, which is probably good news. This again is, actually this is a mix of pink chum and sockeye. Lucy Island, it tends to be mostly pink, and it's pretty consistently sort of 20% of diet. Okay, so the take home is that, yeah, these birds are eating a lot of salmon. But when we looked at some of the other indicators, we got a bit of a surprise. So what we did was we compared characteristics of the salmon that the birds are coming in to feed their chicks with to the salmon that the DFO is catching in trawls that they're running around these colonies. So we can consider that the salmon being caught in the nets by DFO, they do this every year just to get us an idea of the size of the cohort that's gone to sea. So we can consider that to sort of represent what's available out there in the population, because the net is not selective. So we're asking the question, are the birds selective in the salmon smolts that they're coming back to feed their chicks? And the answer is that they are very strongly selective. Okay, so we did this in 2012, 2013. We're just waiting for our results from 2014. The top figure is sockeye. The middle finger Middle figure is pink salmon and the bottom is chum. And on this axis, we're looking at the length of the fish. And on this axis, we're looking at how heavy it is relative to its size. So a weight residual or a condition residual. And so the thing to notice, well, the opaque ones are the salmon smolts that the birds come in to feed their chicks with. The solid ones are what DFO is catching out there in the population. And so you can see that the fish, the salmon smolts that the birds are delivering, tend to be much smaller than the salmon smolts that are being caught by the DFO. Again, this is sort of a random sample of the population. And the other thing is they tend to sit below this line. So what this tells us is that these rhinoceros auklets are taking salmon smolts that are small and that are in poor condition even for their small size. So it's a pretty good example of a predator calling the weak and the sick. And then we had some work we did with Christy Miller where she looked at disease profiles in these salmon that the birds were feeding on. And what she found was that the predated fish compared to the trawl fish tended to be carrying higher diversity of microbes and that they tended to be carrying higher loads of microbes. So the birds are catching salmon smolts that are small, in poor condition, and diseased, compared to the salmon that are just sort of out there in the population. So it was a great relief to me to see all of this because I think what we can easily argue is that at the population level, predation by the birds is probably beneficial to the salmon stocks because what they're doing is removing these fish that weren't going to survive anyway and eliminating competition for the fish that were going to go on to survive. So yeah, that was great news. Okay, the next conservation issue was habitat loss, and the species I want to talk about here is another important bird in British Columbia, the marbled murrelet. Another bird that breaks a lot of the sort of the seabird rules. It does lay a 1-egg clutch. They do have a fairly high survival rate, but they're non-colonial, and they nest on branches, on old-growth trees. And so they were assessed as threatened in 2012 by the Committee on the Status of Endangered Wildlife in Canada. And the threat in particular to this species was identified as loss and fragmentation of old-growth nesting habitat. There's some concern, or was some concern about other factors, the same sorts of things that you would expect to affect any bird on the water, like possibility of oil spills and entanglement in fishing gear. But the big concern for this species was the threat of the loss of fragmentation of old-growth forest. And so this guy here, Long, who I don't know, modeled the situation in British Columbia, and nobody's going to be surprised to find out that there have been declines in the extent of old-growth forest in British Columbia between 1978 and 2008. So this species was listed not because it's not an abundant seabird, but because there's a recognized threat, and that's loss of the habitat they require for breeding. Okay, rather than habitat loss, we can think about habitat protection. This is something Environment Canada has been working on. We've been trying to get a marine wildlife area designated around the Scott Islands to protect important foraging areas for the birds on those colonies. We've been at this a long time, and I'm hoping it's coming to conclusion, but I guess only time will tell. Okay, another serious threat to seabird populations in British Columbia, especially in British Columbia, it's quite a serious issue here, is the introduction of non-native predators to breeding islands. So there's a couple of good examples. Mink and raccoons were introduced to two of the inner Scott Islands, Lance and Bairnsford Island, and they eliminated, actually they were introduced in the 1930s. They're still out there. They've eliminated breeding populations of Cassin's auklets and rhinoceros auklets off those islands, and when we had an archaeological crew go out there and do a dig in the midden, the First Nations midden, we found that, in fact, the birds bones were showing up in their middens. So probably the First Nations were feeding on them out on those islands. And one of the things we would like to do around this Scott Island Marine Wildlife Area is to see if we can restore those islands by removing the introduced predators. Yeah, so we're hoping to get that done. In Haida Gwaii, raccoons were introduced to the main islands, and so there's huge raccoon populations on Graham and Moresby, and every now and again when density gets too high, they swim out to the seabird colonies and they can have devastating effects. It's especially a problem on, say, the east side of Moresby Island. Not much really can be done about it because the populations on the source islands are so large and the islands are so large. It would just be, I mean, almost an impossible job to remove them. The other introduced species in Haida Gwaii that's caused some problems has been rats. So you might have heard of the situation on Langara Island where rats were introduced there probably during the Second World War. They decimated what was probably historically the largest ancient murrelet colony in the world. Some estimates suggest there were 200,000 pairs breeding on Langara. It's down to about 25,000. The rats were removed in the mid-90s by Environment Canada, and populations are rebounding, but it's been much slower than we had expected. But they do seem to be recovering, so it is a good news situation. There's some islands on the east coast in Guayhanas National Park. The park folks have been doing a good job getting rid of rats from some of the islands. I think Murchison and Faraday and Hot Springs up in this area here, and I think they found that they're successful. So rats have actually eliminated some seabird populations here. They eliminated seabirds on St. James Island. They eliminated seabirds on Cunget. So having completed this successfully, I think the plan is now to move south and try to restore some of these islands further south. Okay, and I think this is the closing slide, actually. And this is what we're now calling a native invader. So we talked about the effect that bald eagles can have on seabirds. And this, what we saw on Triangle Island, is not restricted to Triangle Island. Recovery of bald eagles, so you probably know bald eagle populations were decimated by the use of DDT and pesticides. Those pesticides were stopped. Use of those pesticides was stopped in the 1970s, and eagle populations have rebounded right across the range from California to Alaska. So we've got many, many, many more bald eagles out there nowadays than there were 40 years ago. And it's one of the great conservation success stories of all time, absolutely. But we've seen the sort of effects that the bald eagles can have on the seabirds on British Columbia. We're seeing much the same sort of thing happen on the offshore colonies, common murres and cormorants, in Washington State, in Oregon, as far south as Central California. We're not seeing the same sorts of things because bald eagles have not recovered yet in Southern California. Same sorts of things going on the East Coast. In Maine, there's huge concern about the effects of rebounding eagles on seabirds. In Northern Europe, there's concern because Steller sea eagle, which is the European equivalent of the bald eagle, is rebounding in exactly the same way and seriously impacting seabird colonies in Northern Europe. So it raises a bit of a, like from a management conservation perspective, it raises a bit of a conundrum because really this is just the return of a predator that belongs in these systems. So you think, okay, but we really shouldn't be too concerned about this. It's what we call a shifting baseline. Maybe there's just a lot more seabirds now than there were historically, and the eagles are just sort of restoring us, moving us back into a natural order. But the concern is that, yeah, okay, it's great news that eagles are coming back, but they're coming back into a very different world from the world that they left. And so trying to get some idea of what the historical balance was between bald eagles and seabirds is going to be a major research challenge, but I think it's something we're probably going to have to try to grapple with. Okay, so to summarize this last section, climate change could affect seabirds if, as predicted, it results in warmer oceans and increased frequency of extreme climate events. Seabirds can be impacted both by catastrophic and chronic oiling events. Fisheries can affect seabirds through a variety of mechanisms, including prey depletion. Not a problem in British Columbia because, well, outside possibly of the Salish Sea, there's no suggestion that forage fish fisheries are having any effects because basically there are no forage fish fisheries except for herring. Oiling, just the discharge of oiling from fishing boats, and entanglement in gear, which we've seen as a particular problem for species like rhinoceros auklets. Basically because what the salmon, the fish that the fishers are going after, those are the same things that the birds are looking for. So the birds and the fishers are going to tend to overlap in the same area. So there's a potential for problem. Marble murrelet was listed by the Committee on the Status of Endangered Wildlife in Canada due to loss of old-growth forest habitat. And introduced predators, rats, mink, raccoons, have had dramatic effects on burrow nesting seabirds in Haida Gwaii and in the Scott Islands. Okay, and that's it. Lots of people to thank. I'll just let you run through the list. Special thanks to Saul Schneider, who was my boss for a couple of years. He rigged us up a really fantastic basketball net out on Triangle.
You want to do some question and answer? Do we want to do some questions? Does anyone have any questions that they would like to ask Mark before the evening is over? Okay, I'll come on over.
Thank you, Jonathan. So for the warm water mismatch, I noticed that there was a graph that had a proportion of copepods in the diet and that the proportion had lowered. So what made up the percentage of diet during those warm water mismatch years?
Okay, so in the warm water years, euphausids tend to dominate the diets. 3 species of euphausids. I don't know if you're interested in zooplankton. Thysanessa spinifera, Thysanessa inspinata, and Euphausia pacifica.
Do they have a lower quality nutrients?
So the thing about these copepods, I mean, there's a variety of things. First of all, they're large. They're incredibly obvious to the birds. You can see them in the water. They're like orange beads. They're very, very rich in lipid, and they tend to congregate. The birds know where to go get them. They're found right out at the shelf break. So it's like, okay, I'm going to get some of those things. They go out, they're easy to catch, they're slow, they're lipid rich, they can just load up on them. The system breaks down a little bit when those things aren't available because then they have to go looking. So the key to the thing is that, yes, they're very nutritious, but the other half of it is that the birds just know where they're going to be.
Thank you. Are plastics showing up in the feed of these birds?
Yes. At this point, we've got pretty good information for seabirds from the Arctic that plastic ingestion is a pretty serious concern. There's good information on the East Coast that the birds are ingesting a lot of plastic. I would say we're not as far along in getting a handle on this on our coast, but over the last 3 or 4 years, we have started into looking at it. You definitely do find plastic, especially little beads, which the birds probably misidentify as, copepods and things like that, so they're happy to peck and so when you cut open the stomachs of a dead bird, say that's washed up on the beach or something, when you cut the stomach open, you do find plastic particles in the stomach. Northern fulmar on this coast seems to be a species that's particularly prone to picking up plastic.
Mark, just as a follow-up, this is Jonathan. We've started talking a bit about microplastics these days. And the plastics you were talking about, I think, would fall under the category of macroplastics, so bigger. So microplastics, have you done any work looking at the microplastics going into birds? Or is anyone going to be looking at that in the near future?
So one of my colleagues, Pat O'Hara, he's an Environment Canada employee, but he works over at the Institute of Ocean Sciences in Sydney, and I think it's something that he's quite interested in.
I'm waiting for a question to come in on the iPad. He's sending it in, so we have time for a question in between if you squeeze one in. Okay, here we go.
So you may have mentioned it, but what happened in 2007 when there was no upwelling in the northern Vancouver Island? Is there any oceanographic phenomenon or anything going on?
Not that I know of, but the 2007-2008 was really an interesting year because there was a huge change in the oceanography across the entire North Pacific. And there's a suggestion that there might have been a flip in the Pacific Decadal Oscillation in that year. But how that relates to the particular event in 2007, I'm not sure. It was just a very late spring transition. And what causes that, I couldn't say.
Okay, so we have a question from one of our online viewers, Emily. How does the device that detects light variations indicate the travel pattern of the bird?
Okay, so the idea is you ground truth those devices where you're going to be deploying them. So we ground truth all those devices on Triangle Island. The device knows what day, what time it was ground truthed. It knows where it was ground truthed. So any movement away from that, calculating based on the change, well, north-south, the number of hours of daylight, and then over the course of the year, decreasing sunlight through the, through the fall and winter, increasing again in the spring. Somehow it manages to make all those calculations until you figure out where the bird had been.
All right. Okay, so what I'd like to go ahead and do.
I think Pat's got a question.
Oh. Okay, so let's go ahead and conclude our last class for the marine life course. I'd like to thank Dr. Mark Hipfner for coming tonight and talking with us.
Thank you. Yeah, I
about
enjoyed it.
For everybody who's in the class, tomorrow I'll be sending along an email to you to let you know about the exam. If you're interested in taking the exam to get the certificate for completing the class. So we'll send along an email tomorrow. It'll have instructions on how you can log into the exam. You'll be able to set up a user account and take the exam anytime over the next month. You can start it and then come back to it later if you like. And if you have any questions during the exam, you're welcome to, it's an open note exam, so you can look at your notes, you can go to the internet. Just ask that you don't work together as a group to do the exam, but something that you do on your own and use resources available to you. If you have questions, contact me and let me know if you're having any trouble logging in or anything like that. I also sent along a survey, I think earlier today, asking if December 2nd would be a good time for a get-together. So consider that, and when you're thinking about how long it might take you to take the exam. So we just want to make sure that it makes sense for us to have a graduation ceremony if people have actually completed the exam or not, because we can't do it until we've had people complete the exam. Does that make sense? Okay. It's been a real pleasure having you here and seeing you come back each and every time. I feel like it's been a little bit like a proper class, and we've gotten to know some of you, and some of you have even become volunteers here at the aquarium because you've been coming and really enjoying the class. Next year we'll be looking at doing an Arctic class, so we're not sure exactly what that'll look like, but you can keep your eyes open for that, maybe in the fall. So it'll be Arctic themed. And if you have any suggestions, feedback, we'll send along a feedback form pretty soon, so you can send us some feedback and let us know how the course was, and be happy to hear from you. If you have any questions, I'll be around today. Thank you very much. Take care. Good night.